Good afternoon, everyone. Today's topic is on tabular queue networks. And in that tabular queue networks, one of the topic very important is dynamic programming. So finally, this is a short session on how we plan with dynamic programming in reinforcement learning. So DP, that is program dynamic programming, forms the bedrock of planning in reinforcement learning, requiring a complete understanding of Markov decision process, including its transition, probabilities, and reward function. So in our previous session, we had covered the Markov decision property, which says that whenever we want to calculate, reinforcement learning is a part of machine learning. Machine learning is a prediction technique. Reinforcement learning is a prediction technique, a specialization prediction technique of machine learning, which is evaluated based on feedback and reward based mechanism. So Markov property says that the predicted value, if you are in a present state S and we are calculating the next state S dash. So S dash will be calculated as per the current state S. So if we try to evaluate, for example, emotions, तो अगर पहले वाला इमोशन सैड था, अभी का इमोशन हैप्पी है, तो आगे का इमोशन एज पर मार्को प्रॉपर्टी एस डैश will be based on the current emotion. So it will be happy, not sad, क्योंकि पिछला वाला नहीं देखना है, current देखना. And then after the Markov property, okay, and Markov chain is like that. When we calculate the next state, we consider the present state. So we have been taking these lecture series where Markov property is based on it is conditionally independent of the past. Okay, तो हम आगे का जो भी predict करते हैं, that is only on the basis of current state. That is called as the Markov property. So S t plus 1 is calculating all the present states of different scenarios. Markov chain is a sophisticated process that satisfies the property. तो आगे जो जो chain हम बनाते जाते हैं, that is based on the present state. फिर उसके आगे वाला state will again calculate its present state and calculate the next state. So that is called as Markov chain. Concept is very simple, as though the words look quite complicated. Then Markov reward property, we told that reward basis does not consider actions, whereas MDP, they consider actions. So what are the different components of MRP? States, transition probabilities, reward function, and discount factor. Okay, so we have already taken this lecture earlier, but just a revision that there are 4 things that are considered in MRP. What is extra in MDP? All things are same as MRP. Extra is actions. So in MRP, we do not consider actions. We just consider the states. And depending upon that, and the reward function, that value function which the company decides, who incorporates this reinforcement learning. And according to the discount factor and reward function, okay, transition probabilities are decided. And the S dash is calculated. But in MDP, apart from all this, the actions are also taken into consideration with the state. So the entire concept behind MRP and MDP and Markov property is Bellman expectation equation. That also we have done in our previous recordings. I'll share you in the description box as well, or you can go to the playlist series of our machine learning and reinforcement lectures. So the entire Bellman function is based on the reward, discount factor, and the probability. So this is the value function, how it is calculated based on the summation of the transition probabilities and the reward based on the state. Okay, so this does not consider the action. So if you see over here, all the parameters related to MRP is there in this value function. A is not considered, that is action is not there. Okay, so we go ahead with MDP, which has actions. Now, in the actions, a policy defines the agent's behavior, where you can have 2 types of policy, deterministic and stochastic. So deterministic is where there's exactly one action to take place for a given state. Whereas stochastic, you have to consider the probability of taking an action A in the state S. Because see, machine learning is based more on the stochastic policy. Why? Because you are predicting, and predicting may have a probability. For example, today if you are weather forecast is also prediction. It is just a prediction that there's a probability that today it will be cloudy or it will be rainy or it will be hot. You can't determine that it is going to happen 100%. Okay, so you can also relate to hard computing and soft computing. So machine learning comes under soft computing applications. Nevertheless, MDP is applicable to both hard computing applications as well as soft computing applications as well. Okay, but majorly it is more applicable to stochastic policy. So we were back to our the topic, that is um, dynamic programming, where we have got these extra things to be covered to more improvise the MDP. So in MDP, we have got transition probabilities and reward function. So we are going to enhance the MDP with the help of dynamic programming policy. So these are the four components which you need to cover. So I'll also share you in the description box the textbook link of this subject, also my book chapter series. So you can go through this topic in through diagrams. So basically, policy evaluation, it computes the value function for a given policy. Policy improvement updates the policy. Okay. So this computes the value function. For example, in our previous case study, we had taken about the gym. So gym will try to finalize what policy it will be giving to the gym clients as per their weight reduction or their dedication or the discipline or the regularity. Okay. So they have their own value function. This we have already discussed in the Bellman equation recording. Then we have got policy improvement, where we update the policy to the greedy with the respect of value function. So if we are offering, say, loan to people, so the policies can always change. Today, we may have a high policy. Maybe we have got a lot of funds, so we can low down our what you can say, prerequisites. So that can be your policy improvement, or we can higher our standards, whatever it is. Then we have policy iteration. So it iteratively alternates between evaluation and improvement. Okay. So this evaluation and improvement का जो बीच का part है, that is called improvement. Sorry, that is called iteration. And value iteration, it directly computes the optimal value function. So these things I will try to explain you with the help of this, an example of a programming for loop. Okay. Now, for example, हमने एक for loop लिखा है यहाँ पे, for I is equal to 0, I less than 1, I plus plus. Then we, in this bracket, we have said that B is equal to 2, A is equal to B plus 1. When we say print A, so the value of A is 3, okay, because B is 2, so 2 plus 1 is 3, I is 0. So the value of A, if you don't understand and if you think that I'm going fast, you can see this recording one or two times to understand this, and you copy down this code. So you will get the value of A as 3, 4, 5, 6 up to 9 for this I is equal to 0 and I less than 10. Okay. So these are the four things which we have in our dynamic programming. One is policy evaluation, one is policy improvement, one is policy iteration, and final is the value iteration. So this value iteration is nothing but this for loop. Okay, because on this iteration, this entire policy is going to iterate, correct? So whatever this is in the code, okay, this is your policy iteration. So whatever I've written in the blue is nothing but your policy iteration, because this policy is getting iterated on this value iteration, correct? Now, what about the policy improvement? So policy improvement, it happens when A is equal to B plus 1. So we can more evaluate this as policy improvement. So this is a part of policy iteration, but this particular section gives you the value of A, and A is the outcome. So we are more focusing on what is the outcome. उसी के लिए तो सारा policy लिखा है, right? So since print A से ये समझ में आ रहा है, तो this is our outcome, and our A is getting improvised through this policy iteration at this particular section. That is why this is your policy iteration. Okay, you got my point. This is not visible. We can just highlight it with another color so that it is just for your sake how to. And what about the policy evaluation? The policy is evaluation is on this particular iteration. Okay, so I can put this in different color for you to highlight it. So I hope with this for loop, you can understand how dynamic programming is incorporated to improvise the MDP process through the 4 phases of, uh, upgrading the policy and the value function. In normal MDP, you had value function, right? If in MRP also you had value function using bell map. But in dynamic programming, with these 4 extensive steps, we are trying to improvise the policy on a regular basis, because reinforcement learning is nothing but taking feedback on a regular basis. And what do you do after taking feedback? You need to improvise the policy. Okay. So I think this short session on dynamic programming would be helpful to you. So thank you very much for your patience listening. This is Dr. Ayesha Butalia signing off. Have a nice day.